So now we'll see how we can find the capillary height of a capillary tube, and also we'll try to solve one problem regarding to that in cengage. So first step, determine capillary height in capillary tube. Okay, so first, what is meant by capillary tube? So a capillary tube looks like this. If we let's consider this solution as water, and if we take a glass tube which has both ends open, so like if it depends on the radius. Let's consider the radius in this way. Okay, so for our radius, when we put the glass tube on the surface of the water, or like when we contact it with the surface of the water, so we can see there will be a rise in the water, and the shape that which we'll get here, it would be in the form of upward concave. Okay, this is called as meniscus. And the reason why the shape of the water would be in this form inside the glass tube, we can see that now. So first, when the glass tube is kept on the surface of the water due to adhesive forces. So what is adhesive force? Adhesive force is the force of attraction between two different substances. Like water water here, it will be attracted to the silicon in the glass tube. So that's the reason along the walls it will be moving up, and it would be also moving up. And parallelly, as it is moving up due to coercive forces. So what is coercive? Coercive is attraction between the same type of molecules. Okay, so that's the reason, as it due to adhesive it is moving up. So due to coercive forces, the water in here also it will be moving up, and it will be forming a meniscus. Okay, so this is the basis of capillary tube. So next we'll move on, like what are the forces which are acting, so that how we can find the height of the capillary tube. So we'll see what are the forces which are acting on this capillary tube. So first thing, like uh, due to adhesive force, we can see the molecules of water, they will be moving upwards. So there is an upward force here. If we take like at any point, if we take the circumference of the glass tube, it would be just like a circle. So we can take the let's take it as upward force UF is equal to circumference of a circle, which is 2 pi r, where r is the radius of the tube. Like this is r is the radius of the glass tube. So 2 pi r into, like there is a force which is responsible for moving the liquid upwards. So let's consider it as capital A. It is adhesive force. This is upward force. So what about the coercive force? Like if we consider here, due to gravity, what happens? The water will try to move downwards. So this force, let's consider it as downward force, which is equal to normal, which is mg. And we already know mass can be written as volume into density into g. And again volume, if we look at here, if I take out the uh, structure of the water, it would be just cylindrical in shape. So if we take volume can be written as volume of cylinder is pi r square h. So pi r square into the r here would be the same. Like if we take the r here would be the same that of the radius of the glass tube. So we can take pi r square into h, where h is the height of the water in the glass tube, into g. This is the downward force. So if we take a particular scenario, this upward force and downward force both will be equal. So upward force is equal to downward force. So upward force we got it as 2 pi r into a. Downward force we can write it as pi r square into h into g. Okay, so we can cancel r and 1r. Pi and pi we can cancel, and if so, from here h is equal to 2a divided by I think I missed rho. Rho, oh yeah, h into, I think I missed rho in df. Mhm. We lost. Oh, okay, okay. Why did I miss rho? Volume into rho into g. So volume is pi r square h into rho. Okay, I missed the rho here. So into rho will be left out here, which is uh, the value of rho is the density. So I mean its density. So h by rho g into capital R. So this is the formula for the height of the capillary in terms of A, but we are not sure how can we use this A. So this is called as actually Julien's law, wherein A is defined as T cos theta divided by rho g r, which is equal to h. Okay, so what is this T? This is the tension of the liquid, and this theta is the angle between the angle for the meniscus. If we take I'll take the separate diagram here. So the angle with which it makes with the surface of the glass tube, and the meniscus angle, it is nothing but theta. So we'll be using this one. So this is the formula which would be used to find the capillary height. So we'll take up a problem, and we'll see how we can solve for the height of capillary using that. Let's take this question. A glass rod of diameter d1 is equal to 1.5 millimeter is inserted symmetrically into a glass capillary. So we'll take the diagram for this. So let's take a capillary tube, and okay, I'm just assuming the radius as big, but like it may be small also. Actually, it's in millimeters, so let's make it small. Okay, so this is the capillary. They said a glass rod of diameter 1.5 mm. So we have kept a glass rod in this capillary. I'm keeping it as black just for the sake to show that it is not hollow. So this is what the condition they gave, and they gave the respective diameters. So the diameter of the glass rod, let's take it as d1 is equal to 1.5 mm. So which is equal to 1.5 into 10 power minus 3, and d2, let this be the diameter of the capillary, which they gave it as 2. As you can see, with diameter inside d2 is equal to 2 mm. So d2 is equal to 2 mm. So which can be written as 2 into 10 power minus 3 meters and meters. Okay, then the whole arrangement is vertically oriented. Already we have taken the vertical orientation and brought in contact with the surface of water. To what height will the liquid rise in the capillary? So surface tension of H2O, they gave it as 73 into 10 power minus 3. So we can use the formula directly here, which we have used earlier to find the height of the capillary. So H is equal to, it is 2T cos theta divided by rho g capital R. So where R is the radius of the glass tube capillary, we can say. But if we look here, if we take this one as R1 and like the other radius as R2, we can clearly see here the water enters only inside this region. So definitely the R would be, I'm modifying the equation again, rho g, it's R2 minus R1, because this is the region where water is entering. Okay, now let's substitute the values. So what about T? T, they gave it in the question itself. It is 73 into 10 power minus 3. So it is 73 into 10 power minus 3 into cos theta. Like normally the angle between this water and this, like the water and the glass tube here, like if we take this angle, we can, like normally it would be 0.8, theta is equal to 0, or sorry, 8 degrees. So instead of that, like cos 8 degrees, so we can approximate it to 0 actually. So we can take cos theta, like if theta is equal to 0 approximately, So cos 0 degrees is equal to 1. So we can neglect this cos theta, we can keep it as 1 divided by rho g, the density of water. So here in the question, they did not mention in the question density, but we already know the density of water is 10 power 3 meters. So 10 power 3 into g value, we'll take it as 9.8 into R2 minus R1. But in the question they gave D1 and D2. So like R2 value would be 1 into 10 power minus 3, because R2 is D2 by 2, and R1 would be equal to 15 1.5 divided by 2 into 10 power minus 3. So it shall be equal to 0.7 to 7s of 14, 0.75 into 10 power minus 3. Okay, so we can substitute the values here. So D2 value, R2 value it is 1, and the value of R1 is 0.75 into 10 power minus 3. I will take it outside. So this 10 power 3 and 10 power minus 3, it will yield us the value 1. So we'll be left with 2 into 73 into 10 power minus 3 divided by, it should be 1. So 9.8 into, and the 1 minus 0.25, so it should give us 0.75, it should give us 0.25. Okay, and here it will be 10 power like it is 10 power minus 2, and it is 10 power minus 3. So here we can find 10 power minus 3, and here also 10 power minus 3. So 10 power minus 3, 10 power minus 3 we can cancel. We'll be left with 2 into 73 divided by 98 into 25. Okay, so we can do the cancellation. 2 1s are 2, 4s are 8, 2 9s are 18. Okay, so 73 divided by 49 into 25. If we simplify it further, we'll get it as 60 into 10 power minus 3 mm. Actually, we have taken it as meters. So 16 into 10 power minus 3 meters. So it can be written as 6 into 10 power minus 2 meters, which can be further written as 6 centimeters. So this is the solution. So 6 centimeters is the height to which the water liquid, in this case the liquid is water. So yeah, we can consider the height to be 6 centimeters. So I think we can just use the formula and we can get the results. Calculation, it can be done in this way, or either we can put the values of D1 and D2 like directly. We can take D1 is equal to R1 by 2, and we can take even R1 in the place of doing, instead of doing this, we can put the by 2 here, and we can take it to numerator, and we can also simplify. Irrespective, we'll get the answer as 16 to 10 power minus 3 meters, and then we have to convert it into centimeters. Okay, thank you.